For science fair, you'll be given a lab report guide, and all week long you have been working on gathering up your materials, perfecting your hypothesis, and everything that we worked on previously with your proposal. Because I'll be printing this out, the first thing you need to do is to put your name, first and last, and your hour. Once you do that, let's take a look. Lab reports are used by scientists to tell the world what they have learned. You will find a list of what needs to be included below. Please review the list and make sure you are clear on what you need to include in your report. A lab report consists of 6 main components or parts. Use this as a checklist for your report. Directions. Inside the box, you will enter your words. When done with that section or box, delete the words I have written. So if you'll look here for title, and I'll just scroll through, you have all these different sections and all the sections have boxes. So what I have done for you is I have, first of all, created a template for you so you don't have to create it. I've even created the titles and the headings of all the template pieces. So here we have title, and I give you hints and tips and tricks. Number 1, your title should be brief, concise, yet descriptive. It should describe the activity or experiment. Absolutely no questions or punctuation should be included, and you have to follow capitalization rules for titles. If you don't know, ask your ELA teacher. So you can do this one of 2 ways. You can either click your cursor here and then enter 1, 2 times down, or you can put your cursor at the very end and click 1, 2 times down. It's a personal preference, and I really don't care how you do it. Just pick one. So I'm going to come up here and I'm going to put in my title. I'm going to be doing an experiment over the different types of materials and which one is the best for keeping ice cold. So as you can see, what I did here, and I'm going to go back and show you again, I went through and I left-clicked the mouse, I scroll the mouse up, and I highlight, unclick, and then I simply take the delete button and I click it, and it goes away. And I will use the backspace the backspace button until there's no spaces above or below my title. So the only thing I'll see in the box is Ice Ice Baby. To give you another example about how you're going to change and delete the things that are in this document that don't need to be there is I'm going to skip down to procedure, experimental design. So let's say that I have already put all of my things in here, okay, all my steps. I did exactly what Mrs. Lewis told me to. I gave a brief description of the experiment. I did that. I did the paragraph. I did everything, okay? So then, once I'm done, I'm going to come up and I'm going to delete it all that Mrs. Lewis put there. I'm going to delete everything Mrs. Lewis put there. Absolutely everything. Because this isn't Mrs. Lewis's experiment, right? This is mine. And so then the only thing you should see left in the box are the things, again, that you put in there. So I've made this lab report guide absolutely foolproof. My middle schooler or even a 5th grader could come in and see what I've done and fill in the blanks. That's all you have to do. Okay, so let's take a look at the rest of it. Observation, what did you notice that led you to design this experiment? And you can't say science buddies. The next section, problem research. This is the part where you state the problem or question you're trying to answer. Not all experiments start with a question. Some start with an observation, and questions develop from further observations. Make sure you include any preliminary observations or background information about the subject. Do not assume your audience knows all about whatever. For example, if you're building a motor and you're talking about pistons, not everybody knows what a piston is. You might need to give your audience some background information on why pistons are important to the running of an engine in a car. So, to help you do that, number 1, what is your goal or your purpose? 2, what idea are you trying to test? 3, what is the scientific question you're trying to answer? And 4, what variables may affect what you're testing? Background information. This should be 2 paragraphs long, maybe 3. This must be written in your own words, no copying and pasting from websites or books. Trust me, I will copy it, I will paste it, and I will find out, so no cheating. Remember to write down the websites and books you use at the end of this document. Include all keywords and any research you did to better understand your topic. Include the definitions of any small words that you needed to know in order to design the experiment. What did you learn about your topic that helped you form your hypothesis? What information will someone read your lab need to know in order to understand your experiment and what it's about? Your second paragraph is all about the question and the purpose. What is the question that the lab was designed to answer? What is the purpose of your experiment? What are you trying to find out? So just to give a quick example here, this is probably your second paragraph where you would say, the question I designed this experiment because, and then you insert what your question was. And then you're going to say, I wanted to find out blah, 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 blah. Okay, and then you're going to come down to number 1, what information did you research or learn that helped design the experiment? When I was researching about prisms, I learned blah, 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 and you answer all that stuff. Number 2, I had some prior knowledge about highlight colors for tie-dye shirts, etc. And I'll talk about that. And then I'm going to summarize everything that I just said. Do you see? So I answered all of these things, but I answered them in sentence and paragraph form. Okay. Next one, hypothesis. If that's what you will be doing in your experiment, then what you predict will happen, because this is your justification based on background information. Number 2, explain how you think your project can demonstrate your purpose. Number 3, make a prediction regarding the outcome, what will or will not happen of your experiment. Number 4, you should be stating the results you were predicting in measurable terms. It's not science if we can't measure it. Based on what you have learned in your research, what do you predict the answer to your question is? So predict what will happen in your experiment, and you have to be specific. And again, this is kind of just a regurgitation. So for your materials, make sure you list all your materials and equipment, include the quantities. You don't have to number like I'm here, 1, 2, 3, 4. Don't number. That's ridiculous. I prefer that you not do it. Include any tools that you'll be using. Include the exact amounts of each material you use. That goes back to quantities. I formatted 3 columns for you. You're welcome. And so here's what you'll do. Just highlight, but not the whole entire thing. Leave number 1 there. And so number 1 should not be highlighted. Hit delete, and that's what it should look like. And then you just backspace 1 punch at a time. And then you can start with your list. Apples, oranges, goats, houses, and you can see how this continues to change as we type. And I'm hitting enter every single time. Next, we have procedure and experimental design. Give a brief description of the experiment in paragraph form. Make sure that you include the independent and dependent variables as well as the constants for your experiment. If your experiment included a control, you should say so. In the above paragraph, be clear about the variables, that's the elements that change to test the hypothesis, versus the control, which is the element of the experiment that does not change and remains constant. How did you set up the experiment? Think of your constants. And how did you run the experiment? And how many times? Or how many times do you plan on going through your experiment? Procedure. You have to give a detailed step-by-step explanation of how you will conduct the experiment to test your hypothesis. This should be so detailed that a 3rd grader could pick it up and do exactly what you did. Sequence in the order that you followed. Another person should be able to replicate your experiment by following your procedure. Here's an example of a procedure. 1. Place 5 milliliters of 3.0 m aqueous HCl in test tube. 2. Add 2.3 centimeters of magnesium ribbon to acid. Record observations. Yes, you have to say record observations. Every single time you need to record an observation, you have to write down that you're recording the observation. Remember that little third grader? If they're going to come through and repeat your experiment, they need to know when to write things down because they cannot just make things up or assume. They have to do step by step exactly what you did. So let's take a look at this here. When a reaction is finished, light wooden splint. Quickly turn over the top test tube and place burning wood splint near mouth. Now that's how the original procedure was written out. It said near mouth. Well, if I was a third grader or if I didn't know a whole lot about chemistry, I would probably put that on my mouth. So words are important. Make sure you're specific. That's the mouth of the tube. So 1 through 6 is just an example of how we were being specific. Number 4, you will leave this number 4 how to here until your experiment has been completely completed. How did you measure or calculate things? And how did you record the data? Think of the dependent variable. So again, this is going to be a paragraph form. 1 and 2 is going to be paragraph. It's just boom, you're going to have a paragraph. So it'll say procedure, experimental design. You'll have a paragraph, and then you will have a very long laundry list of steps, and then you will have a final short little paragraph. You can say, in order to measure, etc., this is how I did it, and this is how I chose to record my data. Very easy. Observations and data. Clearly, this portion will not be able to be completed until during and after your experiments are completed, so leave it alone until you have reached this point. You should have your data table ready before your experiment. You can read this on your own. Data analysis, again, you will be reading this on your own. Discussion and conclusion on your own. References, let's talk about it. You must include the name of the website. So if the name of your website is Facebook, write Facebook. You must include the URL to the actual section of the website you were on. So if you were on a particular page inside Facebook, it'll give you this big long URL at the top. Copy it and paste it here. You must include the date you retrieved the information. So I retrieved the information September 13th, 2018. And you have to bullet point each reference. So it should look like this. Facebook, here's the URL, and here's the date. By November 1st, you should have a minimum of 5 sources, and you may have other references, but at least 3 of them have to end in edu or .gov. If you have any further questions, let me know.